Okay, so welcome to part two of the climate change discussion. So the first part, we talked about the basic science behind climate change, how that's completely non-controversial. We know that the greenhouse effect makes life possible on the planet Earth. The second thing we went over is that we know we know how the greenhouse gas work, or excuse me, the greenhouse effect works. We know what greenhouse gases are, CO2 and methane being the two primary among them. And the second thing we know is that humans are causing those concentrations to increase. And we know that those concentrations are primarily due to energy use, specifically fossil fuel use. Okay, so those are established facts. There's no dispute, there's no legitimate dispute on those facts. Okay. The third fact is that the climate is warming and oceans are rising and that the sea ice is melting. Okay, so there's a little bit of wiggle room, a little bit of controversy on exactly how much warming has occurred, but this is from NASA, really obviously well-regarded scientific body. And this shows the temperature anomaly, which is the temperature change over time since 1880. Use my little laser. 1880 through this is like 2022 when this, from the data. And what this shows is these are global temperatures every year. Okay, so every year since 1880. And if you took the average of all of these, took all of them up and find the average over that 140 years, this would be your average. Okay, zero. The zero line is your average. And what this line shows you is during that year, is it above or below average and how much? And you can see, again, you don't need to be a climate scientist to interpret this chart. It's going up, right? Especially since the mid 1960s, early 1970s, it really started to shoot up. So now we're like 1 degree centigrade above the pre-industrial, basically the average, and that's about 2 degrees Fahrenheit. Okay, so about 2 degrees. Doesn't seem like much, but that's a really big deal. Um, so here's excuse me, a little video. I'll just play it, let it play faster here. So these areas show you the blue areas are colder than normal and the red areas are warmer than normal. You can see that's the date at the bottom. This is an image of sea ice melting. That's become a big problem. We talked about the positive feedback loop. You probably heard about the forest fires, which have been increasing, and all else being equal, you have hot, dry weather, you're going to have more forest fires. And we basically keep setting temperature records constantly. And we'll go over some of those facts here in a minute. And here's a really nice illustration from NASA that shows you the temperature anomalies you can see from 1884 to 2021. So this was in your reading, but I want to kind of go over it. So this is going to go from 1884 to 2021, and the blue areas are colder than average over that period of time, and then red are hotter than average. And you'll see, just like in that chart, you'll see the temperature really start to take off in the mid 20th century, right? So here we're at 1884. So we're probably, where are we? Oh, there we are, 1900, 1901. You can see this is colder than average, but the average is brought up because of the recent warming, right? So it looks like it's not really cold. It's colder than the average over 140 years. Okay, so you can see early 1920s, we're about average. Starting to warm up, early 1900s, especially the poles, especially the North Pole. Okay, and you can see it's kind of like cooled a little bit. And then we'll see right around doesn't look too bad, and then early 70s, mid 70s, now we're getting warmer. Now the 80s, you can start to see a lot more red coming out. And it's going to see just a lot of red here. Okay, 1990, here 2000, now we're just setting records left and right. It's just warmer, 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 warmer. It's all the way to 2020. So the pole, as you can see, the North Pole is really in trouble. So if you look now, 2021, that's where we're at relative to the last 140 years. So pretty clear that the temperature has been getting higher overall, and almost everywhere on planet Earth right now, except for a little bit of North Atlantic and some of the mid and South Pacific, they're about average, right? Because they're white and a little bit of blue. Everything else is red, yellow, orange, which means it's warmer than it has been over the past 140 years. I mean, this is really not in dispute. I mean, we know that it's getting warmer. Okay, so I mean, the evidence is all over the place. I don't want to belabor this too much, but if you look at the hottest 10 years on record, now this is from like 2016, I think. I couldn't find an updated table on this. But if you look at the year, and this is ranked hottest to, the top 10 hottest years in the last 140 years, right? 1880 to 2016. You can see a pretty clear trend. What's the hottest? 2016, 2015, 2014, 2010, 20, right? So you just go on down the line. And the story here is that use my laser pointer. The all the hottest years in the last 140 years have been, almost all of them have been in the last like 10, 15 years. So as of 2022, 19 of the hottest 20 years ever have been since 2001. So basically, we set a record almost every year in the last 20 years. Okay, and the other hot number 8 is 1998, so it's not like it was way back in the day, okay? So the trend is really clear. And I want to be clear, we're scientists here, like we can't predict the future. And so we don't know for sure this is going to continue. Based on all the evidence that we have, it is going to continue and probably accelerate. But, it could cool down next year. You never know. It could be an off year. Maybe the next 5 years are a little bit cooler. Maybe there's some extra volcanic activity. Who knows? Okay? It's possible. So this is not an absolute prediction, but all signs are pointing to it as a warming trend, right? So here's the last, the temperature anomaly over the last 140 years, right? So you can see just about, again, that little North Atlantic area is a little cooler, some of the Pacific, okay? I mean, sea temp is 1 degree hotter, land temp is 2 degrees hotter, so it's like 1.8 degree total. 1.4 degrees total. So it's getting warmer, right? So kind of giving you a little perspective here, because we want to sort of think about, okay, we know that emissions are causing all these problems, or we know that emissions cause warming, and we know we're emitting more. So who's emitting the most? This is a really important question. So I want you to sort of jot down your answer here. Which country do you think emits the most CO2? China, US, India, or Russia? And then which emits the most per person on average? China, US, India, Russia. And what about in terms of the entire, last like 200, 300 years, who has emitted the most total? Because CO2 actually can last over 1,000 years in the atmosphere. And so the stuff that was emitted during the early days of the Industrial Revolution actually is, a lot of it's still up there in the atmosphere today, unfortunately. So which of these countries is most responsible? All right, so let's look at some numbers. All right, so this is the total emissions by country. Okay, 1750 to 2020 and 2021 to 2020. Okay, we can see China here, and here's the United States, here's India. So you can see U.S. almost forever. I mean, it used to be the U.K., right, where the Industrial Revolution really started. And then the United States here in purple, we were the world leader since the early 20th century, right? So we were always the top. And then in 2007, China passed us. So China emits the most emissions total. However, keep in mind that China has about 4 times as many people. So if you look at the per person emissions or per capita emissions, the US is about twice or more, 2 to 3 times of the average Chinese person. Okay, so per capita, so again, total emissions, China is the world leader, okay, and they keep going up, right, pretty significantly. But in terms of per capita, US is about 2 to 3 times more than the average China. And then you go down to India, who's number 3 on the list, or now they're number 2 actually. Okay, so number 2 most emissions, India. However, per person, if you look at this chart, this is the tons per person. It's like 2.5 tons per person. The U.S. is like 15-ish tons. So quick math, that's like 6, right? So about the average person in the U.S. emits about 6 times the emission as the average Indian. Okay, and this is all you can play around on this I provided a link and you can play around with the data a little bit. Now, if you look at the total emissions over time, this is the area indicates the amount on this chart. Okay, so you can see the U.S. 399 billion tons over the past 300 years, right? The EU, the entire European Union, 28 countries, 353. Remember, the Industrial Revolution started here, so they got a big head start. U.S. overtook them. China, for all the emissions and all the people that they have, they're still 200 billion tons versus our 400 billion tons. India is like 50, right? So we're, excuse me, 8 times India, twice China. So the point is, the sort of takeaway here is that China is the world leader in emissions. India is now actually second. And that's important. We need to address that. Everyone needs to address it. It's a global problem. But if we look at, like, for lack of a better term, whose fault it is or who's most responsible, it's really the US and Europe, right? So Western civilization. We're responsible for far and away the most emissions that are still in the atmosphere. And right now, per person, US is much higher than China or India. And even in EU, we're way higher than the EU. So you got to kind of look at the whole picture, right? It's not fair just to look at who's emitting the most, but the most per person is really important. In terms of sea level rise, this is something that we know that's happening. We can measure sea levels, and we do every year. They're rising up. Now they don't. It's not like a foot a year or anything, but if you have a couple inches over a decade, that actually can have really big impacts in terms of flooding and during hurricanes, like how much damage happens and so forth. And I just found this interesting. I went to Fox News. I found this somehow on Fox News that they're reporting sea level rise. So Fox News is certainly loath to report this sort of stuff. So if they're doing it, I feel like it's certainly pretty bad if they're even there admitting it, right? Okay, so that's fact number 3. We know that the climate is warming. Okay, so there's really not much debate. The amount of warming, because we don't have a measurement over every square foot of the planet, for the last 140 years, so you have to do some interpolation and so forth. So we're not 100% certain, but we're very certain that the planet is warming. Okay, the 4th fact is we know that if climate change continues to occur, the results will almost certainly be catastrophic, right? You can look at any number of reports on this. If you look at the impacts of climate change, flooding, droughts, crop failure, extreme weather events, disease problems, refugees. We're already having environmental and climate refugees. It helps destabilize countries. So like the U.S. military is really concerned about this. There's some benefits. Like if you live in Canada, you'll probably be able to grow food more, right, for a longer growing season because it's going to be warmer. But then it all cancels out when all the current food growing areas are not going to be too hot or too much rain or too much drought and so forth. And the IPCC, and I'll talk about them in a minute, they say, taken as a whole, the range of published evidence indicates that net damage costs of climate change are likely to be significant and increase over time. So what they're saying is it's bad and it's going to get worse. Okay. As I said, the U.S. Department of Defense, they consider climate change to be a major threat to national security because it causes all this unrest in these other countries that we have to be concerned with. So that's a major sustainability problem. And if you look at, I find this chart really, really interesting and illustrative. If you look at the emissions, who's responsible for the most emissions, that's the top part, okay? And the more bloated countries are responsible for more of the emissions per person, or more of the total emissions, actually. And then this bottom chart shows you the likely impacts from the emissions, right? So all these refugees and flooding and storm damage and all that sort of thing. Like who's going to suffer the most is down here. And if you take a look, right, it's pretty clear that the people that are most responsible are the ones that are least impacted and vice versa, right? So look at the whole continent of Africa. Very, very little responsibility except for South Africa down here. But who's impacted? The countries of Africa are some of the most impacted, right? So that's what you want to jot this term down, climate justice. So there's a climate injustice problem here where people are disproportionately impacted by climate change. And a lot of the major climate change research comes from the IPCC, or the Intergovernmental Panel on Climate Change. Okay, so if you see that term, IPCC, very important. term in this field. And so what they do is they're a United Nations body that they put out these major reports every 5 years or so, and they reports in the meantime as well. And so the IPCC, the reason they're so important, they're made up of thousands and thousands of the best scientists in the world, and they all have to agree on every single word of these, multi-hundred page reports. Okay, so it's very, very top science. They use all the best science, all the best researchers, and they're all part of the IPCC. Okay, and the two major ways to, I guess, address climate change. Number one is mitigation, is what we tend to talk about a lot. That's where we're just reducing our emissions. We want to mitigate the emissions, which means just prevent it from happening. Adaptation is, it's going to happen. There's already been some warming. There's going to be more warming. We can't actually stop some of the warming, and so we need to adapt to that future, right? So those are the two sort of ways to address it, broadly speaking: adaptation and mitigation. Okay, so that's your fourth fact. If climate change continues to happen, the results will almost certainly be catastrophic. The fifth one is that there's broad scientific consensus that that climate change is being caused by humans. Okay, so this is the most recent report, actually. As I record this, this came out in the fall of 2021, and this is the strongest language that the IPCC has used to date, saying that it is unequivocal that human influence has warmed the atmosphere, ocean, and land. So before they're saying, well, we're pretty sure. Now they're saying, based on all the evidence over the past 30 years they've been doing this research, now they're like, this is like, we know that humans are causing the climate to change. So no longer can we say, we're not sure. Okay, it's happening and humans are causing it. We don't know to what extent, but we know that it's happening. Okay, we know that this scale, as I said, the scale is really important. It's unprecedented over thousands of years, probably hundreds of thousands of years. And we know that humans are already impacting climate and weather. Okay? So, again, we know that humans are doing something to the climate. They are causing it to get warmer, changing weather patterns, and we know that the scale of change is it's unprecedented over thousands of years. Okay? There's all kinds of peer-reviewed research on this. There was pretty famous peer-reviewed research that came out a couple years back that found that 97% of the published peer-reviewed experts in the world agree that climate change is likely due to human activities. This is from I think this is probably 10 years ago, so it's even stronger now. You have all these major organizations across the world: the American Geophysical Union, American Meteorological Association, National Academy of Science. These are all really august, major, respected, the top scientific organizations in the world, and they all agree that humans, that we need to do something about this. Okay? So, summary of both of the climate change videos. Number one, we know what the greenhouse effect is. We know how it happens. We know that it keeps the Earth able to be, keeps life going on Earth. Okay? We know this is not in dispute. We know that humans are increasing the concentration of greenhouse gases. That's not in dispute. The climate is getting warmer. That's not disputed either. The extent to which it's warmer is not 100% certain, but we know that it's getting warmer. We know that if it continues to happen, it's going to be really bad. Okay, so it's not guaranteed, but if we head down the trajectory that we're on, it's going to be really bad. And again, there's very, very broad consensus that humans are at fault, right? And there's an article from David McKay, and he one of the things this analogy he uses, he said, look, we're not 100% certain of all the impacts. We're not 100% certain of how much warming we're causing. But here's the thing: if you're driving a motorcycle really high speed and you know you're near a cliff, but you don't know exactly where that cliff is, you would think you would slow down, right? You want to prevent the worst case scenario. And it's the same thing with climate change. We don't know the exact extent to which we're impacting the climate, but we know enough to know that it's going to be really bad if we keep doing what we're doing. And that's the precautionary principle. So you want to jot this down. The precautionary principle, this is just a general principle. It's not just climate change. And that is, you want to prevent the worst case scenario. Okay? So there's all kinds of ways to do this. We do this every day, right? Should I speed up and try to get through that traffic light? well, let me weigh my options. What's the worst that could happen? I get smashed and I die, or I kill somebody else. If what's the alternative? I don't speed and maybe I'm like 2 minutes late for work or class or whatever, right? So you were like weigh these pros and cons. You're like, well, I want to avoid that, right? Like let's avoid killing somebody or getting killed, and then then you can sort of weigh the other options. And that's the same thing with climate change. It's like, what's the worst possible outcome? The worst possible outcome is humans are causing all of the warming we're seeing, and we don't do anything about it, right? And that's the worst. That's the worst case scenario. If you weigh all the other options, you say, well, you know, I really don't want to mess with the economy. I don't, I have too many people working in the fossil fuel industry, whatever. I don't want to change that. So we'll not really do what we need to do to address climate change. And then it's like, you end up not making, and then climate change happens, and you're like, well, I should have prevented that scenario. Okay? So the precautionary principle is avoiding the worst case scenario, and you weigh all your options and you say, well, what can we control that will prevent the worst case scenario from happening? And in terms of climate change, the only thing that we control are emissions. We can't control how the climate system works. We can't control how the earth absorbs CO2. We can control emissions. So that's what we do. We avoid emitting so we can avoid those worst impacts of climate change. Okay? And all that being said, right? If every scientist in the world is wrong and it's all a bunch of hooey and everybody was wrong, right? So all these experts were dead wrong. It's happened in the past. It's been a really long time. But let's just say, for argument's sake, that the Earth is fine and it's going to go back to the climate that we had 50 years ago, 100 years ago. If we do take all these steps to reduce our fossil fuel use, to try to mitigate climate change, what do we end up with? We end up with cleaner energy, cleaner air, more democratic sources of energy, right? Like we're generating our own energy. We have our own batteries, so we're not relying on the grid. We have more livable cities, more bikeable, more walkable cities, right? Less pollution. Like air is cleaner. If you look at the deaths and the health impacts of fossil fuel burning across the world, it's just awful. It shortens people's lifespans. There's so many negative effects that we can mitigate by just getting off fossil fuels. So even if climate change isn't as big a problem as we think, it's going to have all these other benefits. And this is a very famous cartoon that sort of illustrates that. So I'll have you take a look at that if you want, right? So worst case scenario, if we do everything we do to try to stop climate change from happening, and we're totally wrong, then we still have a more livable planet at the end of the day. Okay, so that's it for the climate change lectures.